This is our last section for section 6, where we're going to be talking about naming acids. I believe this is section 6.8 in your textbook. Before we do that, we need to define what an acid is. An acid is a molecule that can donate a proton or accept an electron pair in reactions. And in this class, we're just going to be focusing mainly on the first part, which is that an acid molecule is something that can donate a proton. And a proton is a hydrogen with a positive charge, okay? That's what we mean by a proton. So with that knowledge, if we wanted to write something called an acid ionization equation, what this would look like is if we had a hydrogen, okay, or a proton attached to some molecule where X is just representing the rest of the molecule, what's going to happen is the molecule is going to give up the proton, okay, lose the proton, and it's going to become itself an anion, all right? So it gets rid of the positive proton, it's going to get a negative charge, okay? The anion is here. Okay, so this is what's going on during the reaction here, the ionization equation, I should say. The molecule or the acid is giving up a proton or donating a proton. So there's a few different types of acids then. There's monoprotic acids, diprotic acids, triprotic acids, polyprotic acids. Really what we mean by this, if you have a monoprotic acid, the acid can give up one proton. Okay, if diprotic means it can give up two, triprotic can give up three, and then polyprotic is kind of an umbrella term. It means it can give up, it's any acid that can give up more than one proton. So these are the types of acids, and that might be further classified into these two different types. So you have oxyacids, which contain oxygen as well as hydrogen and other nonmetals, like the guy shown here on the right. And then you have binary acids. They consist of hydrogen and one other nonmetallic element. So this is hydrogen and a chlorine. So these are the acids that we're going to be seeing throughout the class. Not just these two, but these types, oxyacids and binary acids. So how do we name these acids then? Well, acid nomenclature, here we go. So this is for oxyacids now. So I'll say the rule and then we'll do the example together. So if the name of the anion in the acid ends in -ate, you change the ending of the name to -ic acid. Okay? And if the anion in the acid, its name ends in -ite, you change the ending of the name to -us acid. Okay, so let's do some examples and I think it'll be more clear. So this guy, okay, if you go in your chart of polyatomic anions, this is a chlorate ion. Okay. Okay, and it's just again in that table of polyatomic ions. So this becomes then, I change that -ate ending to an -ic acid ending, and I get rid of the ion part. So this is going to be chloric acid, okay? So the -ic, the -ate became -ic acid, all right? So this is nitrate. This is a guy, okay, ion. So this becomes nitric acid. Okay, that -ate ending, anytime it ends in -ate, you change it to -ic acid. You get rid of the ion part, okay? So that's why it was really important for us to learn the names of these polyatomic anions, or to at least have the chart in front of us. So finally, this is bromate ion. Okay, so this is going to be bromic Okay, where again, that ic acid is the 8. And the acid part of the end of the name tells us we have that proton there in the front. So don't worry about including hydrogen or proton or anything like that in the name. You just follow this rule. Find the name of the anion and then change the ending, in this case to ic acid, or as we'll see in the next examples, to us acid. Okay, so let's keep going. So if you look on your chart of polyatomic ions, this is a chlorite ion. Whoa, don't know what I'm spelling there. Okay, so this part is a chlorite ion. So it has an ITE ending, okay? So that means that ITE ending gets changed to us acid. So this is chlorus. Okay. Acid, where again, that ITE ending got changed. Same idea, this is nitrite ion right there. So this is going to get changed to nitrous acid. Not nitrous oxide for anybody that likes the Fast and the Furious, nitric or nitrous acid. Okay, so I'm going a little fast here because we have plenty of examples coming up in the next slide that we're going to do together. So this is just for the rules. Okay, this is bromite. So this is bromus acid, okay? All right, so this is the rules for naming acids. So let's do examples together. Oh, finally, let's, hold on. Let's not do examples yet. Well, we haven't talked about binary acids yet. So that was all for oxyacids, where you have hydrogen, a nonmetal, and oxygen. Now let's go to binary acids, where it's just hydrogen and an element. So if the anion in the acid ends in IDE, like a chloride ion, change the ending to ic acid, okay, and add the prefix hydro to the name. Okay, so this is, for example, let's do some here. So this is chloride, right? Ion, right? IDE ending. So this is going to be changed to hydrochloric acid, okay, where I added those guys. So IDE ending gets those three things added, okay? So this is a bromide ion right here. So this is going to be hydrobromic acid. Okay, so I think you're getting the idea. This is iodide. So this is now hydroodic acid. All right, so that's for binary acids. That's the rule, okay? A little bit different than with oxyacids. Okay, so like I said, there's tons of examples right here. So what I would do is pause the video and do these examples. And what I've done, I've given you the names of the anion portion. So you can use the same rules that we talked about before. If it's an oxy acid, if it ends in ate, change it to ic acid. If it ends in ite, change it to an us acid ending. And if it's a binary acid, you do the rules we just talked about. So pause the video, and given the names of these anions, write down the formulas of these acids. Okay, so let's do this together. So this guy is a perchlorate ion. So remember, it's an oxy acid, and that means the ate ending gets changed to ic. So this is going to be perchloric acid. Okay, so 8 tick. Okay, this is a chlorate ion. So this is going to be chloric acid. Again, the 8 gets turned to an ic. This is a chlorite ion. So that gets changed to chlorus. So chlorous acid. This is hypochlorite ion. Don't worry about the first part, just change that to, excuse me, because it's an oxy acid, right? So it has oxygen involved in it. So this is going to be hypochlorous acid. Okay, this guy's a binary acid, right? So it has a little bit different rules, and we actually already named them in the other slide. So hydrochloric acid. Okay, so this guy is another oxy acid. He's got oxygen involved in his formula. I changed the 8 to an ic ending. So N-ic acid. Okay, same idea here. Oxy acid, 8 ending. So this is carbonic acid. Okay. All right, let's see here. Another oxy acid, 8 ending. Phosphon. Oh, I'm writing just the ion name again. Hold on. Phosphonic acid. Okay. So this is an ITE ending. It's an oxy acid. So this is sulfurous acid. Okay. So again, these are examples of naming oxy acids, naming binary acids, and that's pretty much it for what we're going to be talking about in this chapter with chemical nomenclature. So please let me know if you have any questions. I'd be happy to answer them. And next, we're going to be moving on to chapter 7. I'll see you there.